All right, today I'm going to teach you some cool things about number tricks. We've been working on expressions and tiles and all of that, and we're going to be moving into equations. And so this is kind of our segue into equations. So we're going to follow this sequence here by just picking a number. I'm going to pick 2. You pick a different number than me. And then look around your group. If your group has already started this, go ahead and look and see what other people in your group have picked and see if you can pick a different number than them. All right, add 9 to your number, not my number, your number. Then multiply that result by 3. Then subtract 6 and write that down. And then divide the answer by 3. You should have something different than me at this point because you should have picked a different number. And now subtract your original number. So I'm going to subtract 2, you subtract your number. And what'd you get? 7. Good. Now look around your table. If other people have done it, they should have gotten 7 as well. So no matter what number you choose, the result will be 7. Okay, so this is a cool trick. And I'm going to teach you how to know how to do your own number trick. So this one, everybody ended up with 7. And so we're going to visually see if we can figure out why this works using our explanation with tiles. At the same time, we're going to build onto an expression. So the second I asked you to pick a number, I have no idea what number you picked. So that is actually the X tile, right? Pick a number, we have no idea what that is. So in an expression, well, that's X. Then I said add 9 to it. Okay, well, now you have, after you have 9, you have your X and 9 little ones tiles. And so your expression is that you had an X and now you have X plus 9. All right, so now the next thing is I asked you to multiply the result by 3. All right, so looking at this, when you multiplied your result by 3, the tiles, you now have 3 X's. So now we have 3 X tiles. And then 9 times 3 is 27. Now I don't want you to write 27 little things. Let's just put the number 27 and put it in a box. So we now have 27 ones. Does that make sense? So you multiplied the result by 3. So now for your expression, X plus 9, well, you have X plus 9, and then you multiplied the entire thing by 3. So the X plus 9, because we did that first, you have to put it in parentheses. All right, so now we're going to subtract 6. So looking at your tiles, if you have 3 X's and 27 ones, and I asked you to subtract 6 ones, well, how many ones do you have left? You have 21. So right now, everybody in the room at this stage has 3 times their X's plus 21 ones. Okay? So we're just going to build on to the expression. So the expression now was 3 times X plus 9, and then we subtracted 6. So we just do minus 6 at the end. All right, now we're going to divide the answer by 3. Now think about your tiles. All the tiles, you divide everything by 3. So if you have 3X and you're dividing that by 3, you're now just down to 1X, and then 21 divided by 3 is 7. So now, your expression is just 3 times X plus 9 minus 6, and that whole thing now is divided by 3. And then the next thing is subtract your original number. Well, everybody at the very beginning, their original number was this X bar. We didn't know what it was, right? So then once we subtract the original number, then 7 is what you're left with. And so now what that looks like with the expression, we're just building onto it. So it's 3 times X plus 9, in parentheses, minus 6, the whole thing divided by 3, and then you subtract your original number, well, that's subtracting your X value. So then that's your expression. You're just building onto your expression step by step by step. Now if I asked you down here to write an equation, well, this whole expression, this 3 times X plus 9 minus 6 over 3 minus X, that whole thing equals 7. Okay, I'm not going to explain why this works yet, but it's the tiles that are going to help you figure out why this thing works. Go ahead and move on to the next one. I'm going to ask you, I'm going to still pick 2 for this one, and you, the whole time, I'll just go ahead and pick 2, and you pick a different number. take a minute to fill out this whole chart, and then if you need my help, come back to the video. But right now I want you to stop the video and fill out the whole chart by yourself. All right, so oftentimes people struggle a little bit with the tiles on this, so I'm going to do the tiles with you. If you haven't done everything except for the tiles at this point, definitely look or stop the video and go back and do that, and then come back to just double check. So really, you could just double check to make sure that you did your expression right by just looking here at this right here. The expression, you started with x, you multiply by 3, you add 5, you divide by 2, you add 2, you divide the whole thing here by 6, then you subtract 2. And your result, we're going to talk about what your result is in a minute, because you might notice you probably didn't get 2 here, okay? So let's see if you can figure out what the trick is. And if you haven't figured out what the trick is, you look at mine and then maybe look at somebody else's in your groups and see what they have. All right, so let's do the tiles. So the second I said pick a number, everybody now has that x tile, that unknown. That tile is your unknown. You don't. When you multiply by 3, we now have 3 x's, right? And then when I tell you to add 5, well, now we have 3 x's and we have 5 ones. And I'm just going to go ahead and put a 5 with a box. That just represents we have 5 ones. Then you multiply your result by 2. When you multiply that whole thing by 2, your 3 x's now turns into 6 x's. So I'm going to draw 6 x's. And then, how many ones do I have if I multiply 5 by 2? That's 10. All right, so now I have 6 x's and a 10. And then I'm going to add 2. Well, you just add 2 ones. So now you're at 12 here and 6 x's. So I'm just now going to put a big long thing saying we have 6 of these, 6 x's. All right. Then we divide the whole thing by 6. So the second you divide the whole thing by 6, you have this guy being divided by 6, which now brings you down to 1x, and that guy right there divided by 6, which brings you down to 2. So everybody in the room right now, the way that you kind of interpret this, everybody in the room right now has an x, which is their number, and a 2. So then the second that I ask you to subtract 2, what's left? You take away that 2 and you're left with an x. So no matter what number you choose, the result will be the number you picked, your original number, right? Everybody picked a different number. Everybody goes through, you do the whole thing, you should have ended up with the number you started with. So no matter what number you choose, the result will be your original number. Okay, now, your equation now is going to be that whole expression minus 2 equals, well, your original number? Your original number is going to be x, right? Because everybody in the room picks a different number. We don't know what that is, so we have to call that x. All right, so now, what makes these things work? Well, if you go through, and let's just look at this trick for a second. If you go through and look at this trick, if you just look at the tiles right here, we started with an x. We did a whole bunch of things to the x. We multiplied by 3, and I had a total of 3 x's. Then we multiplied by 2, and I had a total of 6 x's. And I was adding and subtracting some things to the ones. But what's really important is I had 6 x's. Everybody in the room had 6 x's. I then asked you to divide by 6. And then the very last step, it worked because this guy, everybody had an x and a 2. So then if I wanted you to end with your original number, well, that means that I just take away the 2. And that's it, and you're done with your original number. So the thing that I want you to be thinking about, and maybe you've even gotten it already, is that the second up here, I asked you to multiply by 3, and then I asked you to multiply by 2. Everybody multiplied their number by 3 and by 2. That's a total of 6. You multiplied by 6. So then now I ask you later to divide by 6. It doesn't matter how many times I ask you to add or subtract numbers. What matters is the second I ask you to multiply, I have to later ask you to divide. Same if at the very beginning, if I asked you to divide by something, I'd later have to ask you to multiply that, because dividing by 6 cancels out the fact that I asked you to multiply by 6 to begin with. The same thing is true with trick number 1. If you go back and look at trick number 1, see if you can look and see what did I do that I canceled out. So take a minute to look at it and then come back to me. So stop the video and come back and look. All right, so in trick 1, the second I asked you to multiply by 3, so I'm going to go ahead and write this down here. What made it work? When I asked you to multiply by 3, I later asked you to then divide by 3. And these operations canceled each other out. Now with trick number 1, I wanted everybody to end up with 7. And so if you looked back at your tiles, you had an x plus a 7, right? So at the moment everybody in the room had an x plus a 7, if I wanted everybody to end up with that 7, I said subtract your original number. Subtracting your original number means everybody in the room just had that 7, right? So that was the other thing. You subtract original in this case. So when I was thinking up this trick here, I actually had that in mind. All right, so now trick number 2, everybody ended up with their original number. So we kind of already talked about the second I multiplied by 2 and then later divided by 6, so multiply by 3 and then multiply by 2 and then divided by 6, those cancel each other out. So the second I said multiply by 3, multiply by 2, then I said divide by 6, these operations cancel each other out. Now in this case, I want everybody to end up with their original number. So right here in this step, once I noticed everybody had their original number plus 2, if I want everybody to end up with their original number, I just have to ask you to subtract 2, and then you're down with the original number. So here, the subtracting of 2 canceled everything, canceled out everybody's 2, so everybody ended up with their original number. Okay? I'm going to say go ahead and try trick number 3 again without my help. Stop the video and then come back and check to see that you did it. If you really feel like you have this and you're able to work in your groups right now, go for it. Just start working in your groups and talk about it with each other, but only if it's okay with your teacher. Okay, I've gone ahead and filled out the first 3 columns here. If you notice, I started with 2, I ended with 4. If you started with 5, you should have ended with 10. If you started with 6, you should have ended with 12. If you started with 10, you should have ended with 20. Okay? So no matter what number you choose, the result will be 2 times your number, or twice your number. Okay? So now there's one other weird thing to look at here. Right here, this double bracket, I asked you to double your number. So right here, x plus 3 goes in parentheses, double it. And then I asked you to double it again. So then I had to add these big brackets here because I already had parentheses. If you did a double parenthesis, that's fine. But just notice that right there, I want you to actually write out step by step what you're doing. Okay? So here, just to walk you through it, looking at this guy, you picked a number, that's x. You add 3. You double it, so put x plus 3 times 2. You double it again, goes in brackets, times 2 again. Subtract 12, divide by 2, and your result will equal twice your number. Remember, your number was called x, so it's 2x. Right there. All right, so now the operations that undo previous operations that make this number trick work. Well, everybody ended up with 2x, and so you can even see that from your tiles here. Everybody ended up with 2x. One thing is at this point right here, when I asked you to subtract 12, right here, it didn't matter. Like, basically, I knew that I had you adding 3 and I had a 6 and you have this 12 here. You can see from the picture you have this 12. The second I asked you to subtract 12, everybody came down to 4 times their number. And then if I wanted everybody to divide the answer by 2, what I've done is I have taken away the fact that you doubled one of your answers to begin with. But the big thing here that makes this trick work is that I knew that everybody had 4 times their number and this 12. So these 2 things cancel each other out. Okay? The other thing, the second I doubled my answer and then later asked you to divide your answer by 2, that also, these 2 things also canceled each other out. But at this point, I could say, like, this is a trick, because if I said, what number did you start with? You should end up with, if you got 7, you should end up with 14. Like, I would be able to tell you what you end up with, knowing what you started with. You ended up with twice your number. Okay? All right, go ahead and try trick number 4 on your own. Again, I'm going to go ahead and pick 2, so you should pick a different number than me. All right, welcome back. So this one's a little bit harder to see, but if you've done your tiles correctly, it's a lot easier to see what your result is. The very last bit of tiles, this kind of tells you what everybody ends up with. Everybody ends up with their number plus 2, right? So I started with 2, I ended with 4. If you started with 5, you would end with 7. If you started with 10, you would end with 12. If you started with 100, you would end with 102. Okay, so now the tiles are what you look at to really see what makes this work. The main thing is the second I multiplied by 5, I later divided by 5 because that took everybody's 5 x's, 5 times their number, back down to their original number. So if I was thinking at the end, I want everybody to end up with their number plus 2. At this stage right here, everybody has their number plus 10. That's just the way that it is. And then I asked everybody to subtract 8, so then I have their number plus 2. So suppose I wanted this trick with everybody to end up with their original number. Well, at this stage right here, I could ask people to subtract 10 at this point, and everybody would end up here. Here, if I asked everybody to subtract 50, everybody would have 5 times their number. So the tiles just kind of really help you figure out what's going on at each stage, what everybody's numbers look like. The tiles are the unknowns. Everybody has the same amount of ones. Okay, so at this point, if I was like, you know what, I want everybody to end up with their original number again, at this point I ask everybody to subtract 2, and then everybody will end up with their original number. But this particular trick is, no matter what you choose, the result will be 2 more than your number. So 2 more than your number. So then that would mean that the equation, my big equation is over here, this whole thing, all of those steps, is going to equal, what do you think? X plus 2. So that's a 2 right there. So x plus 2 there. Okay? Circle the operations that undo previous operations. It is right here. Dividing by 5 is canceling out multiplying by 5. So there are a few more problems in this packet that I want you to just go ahead and go through and do. I don't have explanations for them, so if you still have questions on it, you can ask me in class. But when you get to the part where I want you to start making your own number trick, tune back in so we can talk about it just a little bit. I'm not going to tell you exactly how, but I am going to give you some pointers. So stop the video and then tune back in when you get to the part that looks basically like what you're staring at on your screen right now. Good luck! Okay, so when you are creating your own number trick, what you really want to be thinking about is, what would the last picture be? Okay, so if you think about, if I want your whole number trick to end where everybody has a 5, if you go through and do all your tiles, your last picture will be 5 ones, right? That will be your last picture, 5 little ones like that, okay? If I wanted everybody to end with the number you started with, the picture will look like this. It will be an X, right? That's the last picture. If I wanted everybody to end up with 3 times the number you started with, well, your picture would be 3 X's, right? If I wanted everybody to end up with 4 more than the number you started with, then you would have your number and 4, right? 4 more than the number you started with. So now what I want you guys to think about when you're creating your own number trick, before, like, you just play around with it. Start with pick a number, right? So just don't write this, just look. If I say pick a number, everybody right now has a number, okay? If I say add 6 to it, everybody has their number and 6, right? If I say multiply by 2, everybody has 2 times their number and a 12 at that point, right? So, like, let's just think about the picture. Just this little step right now, suppose I want everybody to end up with their original number. Well, what am I going to ask you to do at this point? Well, I'm going to ask you to subtract this, right? If I want everybody to end up with 6 at the end, I'm going to ask you to subtract this, right? So just think about where you're headed and where you're at each single step. That's all I'm going to say about creating your own number trick. Definitely help each other out, try it out on each other, and then we'll talk about it more in class. Good luck.